running behind Google? It is basically running the Dijkstra algorithm. Some modifications are there like A-star, shortest path finding algorithm, single source shortest path finding, and the Freud version, which is the multiple source path finding algorithm. As it is clear from my diagram or from my picture that in mobile phone someone is searching for the shortest path. So what is the algorithm running behind it? Has anyone thought about what is the algorithm, how we can optimize it? So I have presented this thing that how we can optimize this existing algorithm. This is the process flow. My flow includes the introduction, research objectives, literature review, existing problems, theories, algorithmic discussion, the methodology which I have used, result and conclusion. Introduction. In graph theory, detection of the shortest path is one of the very significant topics and used in various networking areas such as the fire station services, some of the transportation services, logistics. Everyone needs shortest path. Everyone wants that we should travel with the minimum cost. So in this study, I have considered a graph, considered a bidirectional graph for the application of Dijkstra algorithm. My research objectives are, I have compared the Bellman-Ford algorithm, Freud version, Dijkstra algorithm, and the proposed modified Dijkstra algorithm. My basically theory relies in the proposed modified Dijkstra algorithm with the adaptive penalty function, which basically assigns an adaptive penalty function with the existing Dijkstra algorithm to improve the computational time. As our conference topic is conference on computing, communication networking, so I have worked upon that topic only. I have improved the computational time of the existing Dijkstra algorithm. So basically, there were the problems with there were existing problems. It is a simple weighted graph. This is the graph which I have worked upon. This graph, I have made this graph, and the work which I have done is, you can see the nodes. Nodes 0 represents Bathinda, 1 Mopa. It is basically on Punjab only. I have my investigation studies based upon traveling from Bathinda to Chandigarh from node 0 to node 6. We have to find the optimal paths. It is a weighted graph, you can see, and this is the graph matrix showing the node connectedness. You can see how the nodes are connected. And this is Dr. C.W. Dijkstra, who has made this algorithm. So somebody, if we can elaborate this, at some time Dijkstra wanted to meet his girlfriend. It's a very story. During his school days, so he was very eager to find the shortest path. By this way, you can remember how he got to find the shortest path, how this idea came to his mind. So Dijkstra once want to meet his girlfriend before her parents come to his place. So Dijkstra thought that how should I go? Initially, when there was no algorithm and Dijkstra reached her parents were at the home. So Dijkstra got the inspiration to find the optimal path. How he should find the optimal path so that he could reach her friend's home before her parents came. Now Dijkstra algorithm, this is the pseudocode. Initially, we are setting all the nodes to 0. Okay, proposal. Sir, firstly, before going to the proposed algorithm, this is the source node 0 and target is 6 Chandigarh. And this is the path followed 0326. This is the optimal path according to Google. According to Google, this is the computational time by my algorithm. Computational time. And I have created a web application in which I have created this web application which is telling the optimal path with the distance in kilometers. And also I have made the ticket booking system. Also made a ticket booking system. Now this is the work which I have done. In the modification of Dijkstra algorithm, basically I have integrated an adaptive penalty function. So what is the adaptive penalty function? As we know that in the graph only attributes are given. But do you think that only attributes are sufficient for calculation of the shortest distance? I didn't know. There can be some extra factors. Suppose in the edges are basically the paths that we are saying. There can be factors like traffic congestion can be there, some blockages can be there. So how to identify? So with the help of gross positioning system, we can identify the gaps, we can identify the what are the flaws in that path. So that will represent to the penalty. These will be the penalties. So the nodes, penalty can be assigned to the nodes as well as edges. So I can explain in code also. Can I use your marker? So let me explain you all what the work I have done. I have considered two algorithms. One is the edge penalty function, EPS, which basically means we are assigning penalty to the edge. Basically, the penalty function is assigning the set of real numbers, which is basically represents the penalty, the set of real numbers.
No, I can understand from here itself.
It is the edges. Basically, what this P function is doing, it is assigning the penalty.
If it goes to a wrong step, it is a penalty is coming.
Yeah.
Right? If it goes to a right step, there is no penalty.
Sir, actually the issue why penalty is assigned is suppose there can be factors like traffic congestion is a factor. So we can I have formulated the formula. Let me show you the formula, sir. Let me show you.
Sir, I have running out of time. No problem.
Sir, just a second. It will be very interesting.
Okay, fine. Go ahead.
Wi into x. So this is the formula through which I have assigned this penalty.
P of E is equal to Wi plus Xi into Xi.
Wi
into Xi. Who will give the weight actually? Xi is your input.
So actually, let me explain.
Who will give the weights?
Sir, weight. This is already assigned in the. So actually, the weights. Wi represents the importance of weights. It is not actually a weight. It represents the importance.
Importance, yes.
Importance of weight in the edge penalty function. Not in the edge penalty function. Not in the node penalty function. It is in the EPS. And I will talk about NPS, which is a different thing. Node penalty function is different, edge penalty function is different. And the node penalty function says that which is mapping the vertices set of views, which is also assigning the penalty. Penalty is assigned. And how this function looks, PV equal to Wi into Yi, and this Yi represents the number of defects at a node. There can be possible defects also at a node. We can't ignore that. And Wi represents the actual distance here. Here Wi is something different. Here W is something different. Actual distance.
Yeah, understood this one. Okay.
So now let me show the results.
Yes.
The formula is clear. Is this clear?
Next.
And this is the mathematical equation which I have used. The new distance is equal to current distance. So this penalty is assigned to the current node. Current distance represents the distance from the source node to the which is calculated distance, and distance is the from the current node to the neighbor node. That is that, and penalty I have assigned which is already calculated. That is penalty to the current node that I have assigned. So this is the modified, the same thing that I have done here. Now this is the simulation result, which by the modification of Dijkstra's algorithm, we can see clearly that the time complexity is reduced. Earlier it was 15 crore seconds.
I think.
So what is same, but I have calculated the penalties. I have assigned the penalty.
Path is same, right?
Path is same, but sir, computational time is reduced. Path will be same only.
How much is this?
It is reduced by 9 crore seconds. 9 crore nanoseconds. Sorry, 9 crore nanoseconds. Let me show you the comparison. Computational analysis of the algorithm. This is the modification Dijkstra's algorithm. The time complexity is 6 crore, means 0.06 seconds, and it is 0.15 seconds by Dijkstra's algorithm, and Bellman-Ford algorithm is taking 0.29 seconds, and the Floyd-Walsh algorithm is taking 12 crore nanoseconds, means 0.12 seconds.
So
So my work is basically to reduce the computational time. That although it will not be visible to us, we are users, it is not significant for us. But for Google, it is very significant.
Okay, fine. Stop. Because I will answer. Anybody have some questions?
Do you have any questions?
Anybody have questions? So there is one question is, how you will analyze the penalty? Have any proof?
Please
How
repeat.
How you are assigning the penalties? Is there any mathematical proof? Or you are using any functions? Because that is your saying penalty, WA into XI, right? P of E is equal to WA into XI.
Yes, sir.
Who will give that WA actually?
Sir,
What value of WA varies from 0 to 1 or 0 to crore or infinity or what is it?
sir, basically,
The value of W. You can see instead of that, you can apply some iterative algorithm also. The optimum weight will be assigned there such that the penalty will be very good. Right? So instead of that, previously some optimization algorithm they used. That optimization algorithm will fall into local minimum problem. Okay? In order to avoid those problems only, they are coming into deep learning and machine learning techniques. Okay? Apply some deep learning and machine learning for finding the shortest path in the network to assigning the penalty values. That will be very good. Okay?
now some of the limitations.
So if the path is same, how a common man is benefited by this?
No, he is saying that how fast I can calculate the timing.
For this is good for Google.
For
Everybody,
people reduce their
generally, suppose he is shown for only 3 nodes. If it is 2000 nodes are there, the path will be nearly some 10 minutes it will take. If this for a small time, it's a toy problem.
Now for a small it may not be all that different.
It's a practical problem.
So if you have any further queries, you can contact me on this email. This is my contact number. I will surely revert you.
It's okay, fine, good.
Thank you. Thank you very much.
You go, open next week.